This is a question I want my audience to pay attention to. And yes, I put my question marks in there as requested. Why stellar evolution is electrochemical? To have an electrochemical reaction, you need 1. Electrolytes, which are ions, both positive and negative. You need solid metal, or semiconductors. You need heat, light, electric current, friction, and gravitation, to spur non-spontaneous reactions. Some are spontaneous given good conditions for the reaction to take place. The difference between non-spontaneous and spontaneous essentially means if you put the chemicals together, they're not going to do anything. But if you add some heat, then the chemicals will then combine. Or if you add electric current, chemicals combine. Or if you add light, like photochemistry, that's a good study I have to go into more depth with. If you have friction, chemicals combine. If you have gravitation, chemicals combine. Basically, there are many different ways to have a electrochemical reaction. Now, given how much of an electrochemical reaction will take place would be determined upon how much electrolyte material there is, the ions, positive and negative, and how much solid metal and semiconductor material there is. Now, let's go down the line of what a star has. Number 1, does a star have electrolytes? Yes, it has lots of electrolytes. It literally is consisting of all electrolytes, essentially, because plasma is ions, positive and negative. There you go. It's a giant ball, 110 times the diameter of the Earth, completely consisting of electrolytes, basically. We pretty much satisfied that condition. Some young stars are mostly plasma. The older stars become more gaseous and liquid, meaning the electrolytic material is more liquid and gaseous as it evolves. So it's less subjected to electromagnetic forcing as is plasma, being that plasma is, very unruly. Number 2, solid metals. We have an iron core as the star evolves. We have iron in the atmosphere. And we even have silicon in the surface of ancient stars, such as the Earth. Now, I'm not too sure how the silicon got there, but being that we use silicon with a lot of processes inside of our own computers and technology, I guess we can study what a star actually does. If it dopes the silicon, makes it electrically conducting, why it's on the surface, why the star evolves to make a crust that's full of silicon, aluminum and oxygen and that kind of good stuff. But that is worthy of extra study right there. And 3, does the star have heat? Yep. Does it have light? Yep. Does it have electric current? Yep. Is there friction? Yep. That has to do with critical ionization velocity. I'm not too sure how to put critical ionization velocity in regards to the solar atmosphere as the material moves around really fast and causes the material to ionize from its gaseous state, like a feedback loop. But I'll review that in the future. And then you have gravitation. Obviously, these kinds of concepts directly result if the electrolytes can undergo electrochemical reactions with the metals that are inside the star. Which leads me to the very curious realization when I read stellar evolution papers on Archive, which is spelled A-R-X-I-V, and I read a lot of other publications from various other sources. My question is, why are stars not considered to be electrochemical in nature if they satisfy all the requirements of having electrochemical reactions taking place inside of them? If you go on Google and you type in quotes to find the exact term, stars are electrochemical, or stellar evolution as an electrochemical process. Put those in quotes. You won't find anything. You won't find anything at all, actually. Maybe you might find a little bit of things I've been writing. But the simple fact is if we have stars as electrochemical as they evolve, basically, establishment science has been going in the wrong direction ever since they invented the fusion model. Now that we all know the fusion model is a dead end, it's up to my audience to do something about it. Don't just get mad anymore. Try to help me out to solve these problems. Here are the basics. Go ahead. Knock yourself out. Today is June, I believe 13th or 14th, 2015.